Welcome to Math Solution. In our lesson today, we shall be looking at circle geometry 1 chord properties. And in this lesson, we shall be looking at the definition of what a chord of a circle is. Then we'll go into the properties of chord, that is chord properties of a circle. And then we'll take a look at some examples, and we are going to wrap up this lesson by me giving you some assignments for you to try your hands on. So before we go into this lesson, if you are just joining us in this channel, please, I want to encourage you to subscribe. Please make sure you subscribe and view our other videos. And you subscribing will help us to build this channel and reach out to so many other people that have deficiencies in mathematics. So please, we are pleading with you to help us to subscribe to this channel and also watch our other videos, like them, comment on them, and share also these videos with your friends. Let them know that there are math problems being solved in this channel. So now let's get into what we are doing today. Circle geometry 1 chord properties. Now, what do we mean by a chord? A chord is a straight line joining any 2 points on the circumference of a circle. That's what a chord is. A straight line that is joining any 2 points on the circumference of a circle. So if you draw up a circle, say the circle is like this, okay, all right, then this is the center of the circle. Now if I draw a straight line from this point on the circumference to the other side on the circumference, this line that I've just drawn is known as the chord or length of chord of the circle. All right, so that's what we mean by chord. Is a straight line joining 2 points on the circumference of a circle. Now if I also draw up another circle this way, and then this is the center of the circle. If I draw a straight line passing through the center to the other side, we call this the what? The diameter of the circle. So which means that the diameter is a special type of chord that passes through the center of the circle. So that's the first thing you need to learn under the chord properties. We need to know what a chord is, and from what I've just done now, told you that a chord of a circle is a straight line joining any 2 points on the circumference of the circle. Now let's quickly go over to the chord properties of a circle. Now the first chord properties of a circle here says that a straight line drawn from the center of a circle is perpendicular to the chord at the point of contact. If you take a look at this property, it says that a straight line drawn from the center of a circle is perpendicular to the chord. Now if I draw up a circle, say the circle is something like this, okay, now this is the center of the circle. Let's indicate the center of the circle. Now we already know that a straight line from that part of this part of the circumference to the other part is a chord. Now from this property here, it says a straight line drawn from the center. Where is the center? This is the center of the circle. So if I draw a straight line from the center to touch the chord, this straight line is perpendicular to the chord. So since it is perpendicular, it means that it makes angle 90 degrees with the chord. And that is what this particular property is saying, that whenever you draw a straight line from the center to touch a chord, that straight line is perpendicular, that is, it makes 90 degrees with the chord. Okay, now let's go to the second property. A straight line drawn from the center of a circle bisect the chord into 2 equal halves. So if you draw up a circle this way, and then you draw up the chord and indicate the center. Now don't forget from the first property, once I draw a straight line to touch the chord, that means that line must make 90 degrees with the chord. Now apart from it making 90 degrees with the chord, it also divides the chord into 2 equal halves. So if this first part from here to this point of contact is A, and from this point of contact to the other end of the chord is A, then we can from here also calculate the length of chord. So if the chord here is AB, then the chord AB will have length A plus A, and that will give us 2A. This property is very, very important that you know. Okay, so this line from the center of the circle bisects the chord, that is, it divides the chord into 2 equal halves. Now let's take a look at the third property. The third property says that the perpendicular bisector of a chord of a circle passes through the center of the circle. You already know that once we draw a straight line from the center of the circle to touch a chord, all right, it forms 90 degrees with the chord, and also it divides the chord into 2 equal halves. Now let's take some more properties. These are the first 3 properties. Let's take some more properties of chord. Let's take the fourth property of chord. Now the fourth property of the chord here says that the chord midpoint is the point on the chord where a straight line from the center of a circle meets the chord. Now what are we saying here? If we draw up a circle this way, and then we indicate the chord like this, then at the center here, this is the center of the circle. Now once we draw this line to touch the chord, that point of contact where it touches the chord is what we refer to as the word chord midpoint. That is what we refer to as your chord midpoint. So this point of contact of the straight line, which the straight line makes with the chord, we refer to it as the word chord midpoint. So at that point we have 90 degrees, you don't forget, and the line also bisects the chord into 2 equal halves. Okay, so that's what this fourth property is saying. Now let's go to the fifth property of the chord. The fifth property of the chord says here that the chord length depends on its distance from the center of the circle. The chord length depends on its distance from the center of the circle. Now let me draw up 2 circles here. Okay, and then let me draw up another circle here. All right, now in this first circle, consider this is the center of the circle. Okay, now if I draw up a chord such that the chord is quite closer to the center of the circle, that is, the distance of the chord from the center of the circle is small. Take a look at the length, see how long the chord is. Now compare that to this other chord which is drawn far away from the center of the circle. You will realize that in this first chord, the length is longer compared to the second chord. Why is it so? It is so because the distance of the chord from the center in the first circle is short compared to the distance of the chord in the second circle. So what are we trying to say here? The shorter the distance of the chord from the center, the longer the length of the chord. The greater the distance of the chord from the center, the shorter the length of chord. In other words, the chord distance is inversely proportional to the length of what? To the length of chord. So that is what this particular theorem is saying. We are going to apply all this in the examples that follows hereafter. So, but I wanted you to know this for now. Okay, so the chord length depends on its distance from the center of the circle. What does that mean? If the distance is short, the length of the chord will be longer. If the distance is great, the length of the chord will be shorter. And that's why we concluded by saying that the distance of the chord from the center is inversely proportional to the length of chord. All right, let's take a look at the last property of chord here. We have equal chords of a circle are equidistant from the center of the circle. Now, what does this mean? It means that a chord, 2 chords that have the same distance from the center of the circle, okay, will have the same length. That's just exactly what I've explained before. All right, so if for instance now I draw up this circle here, all right, and then I indicate if you take a look at the distance of this chord from here, let's mark it this way, and then I take up the same distance from here, and probably I draw, oh sorry for that, I draw up a chord this way. You see, as long as these two chords, this chord and this, they are at the same distance from the center of the circle O, it means that their lengths must also be equal. All right, so these are the few properties of a circle, of a chord that you need to learn. Now, having understood these 6 properties of the chord, let us now take some examples. Let us take some examples and see how we can apply these properties in solving some problems, okay? All right, now let's take the first example. Now, in the first example here, it says that the chord of length 24 centimeter is 13 centimeter from the center of the circle. Now, calculate the radius of the circle. So, let's take the solution to this problem. All right. So here is the solution. Now, in taking the solution, we need to draw these diagrams. But before we do so, let's represent the parameters. It says a chord of length 24 centimeter. So that means our chord length, I will be using CL to represent chord length, is what? 24 centimeters. Now, is 13 centimeter from the center of the circle. Now, this 13 centimeter is the distance of the chord from the center of the circle. So we call that chord distance, which is D, and we put here as 13 centimeter. Then we are required to look for the what? The radius of the circle. So we say arrow, and then we'll put our question mark. Now let's quickly draw the circle and represent this information in the circle. All right, don't mind my circle, okay? Funny circle. All right, let's get down to business. Now, we are told that the chord length is 24 centimeter. That means we have to draw the length of chord this way, and then we put the dimension lines down to represent the length, which is what? 24 centimeters. So we do this and put your dimension lines this way. Okay, so that's the length of chord, okay? And anytime you draw the length of chord, you must indicate the center of the circle. All right, and then we are told that the chord distance is 13 centimeters from the center. So which means that if I draw a line from the center to touch the chord, don't forget, it touches the chord at the midpoint of the chord, and that means there will be 90 degrees here, and the length of the chord will be divided into 2 equal halves. So if we are having 24 centimeter, then half of 24 will become 12 centimeter, and the other half will become 12 centimeter. So this is the chord distance, which is 13 centimeter. Then we are required to look for the radius. You have to join the center of the circle to the other end. You can as well draw it from here to here. Okay, it doesn't really matter. So, but just follow it up this way. Then let's assume the chord is AB, and this place here as M to represent the chord midpoint. So what do we do here? How do we get the radius R? Now, if you take a look at the triangle formed by the radius, half of the chord length, and the distance of the chord from the center, you will see that we are having a right triangle. And there are 2 principles we use in solving the right triangle. We can use our SOHCAHTOA, or we use our Pythagoras theorem. In this case, we are going to apply our Pythagoras theorem since we are given the relationship between the 3 sides of a right triangle. So we come here to say, using Pythagoras. All right, in using the Pythagoras, the square on the hypotenuse, this side is the hypotenuse side because it is facing angle 90 degrees and it is the longest of the 3 sides. So the square on the hypotenuse, arrow square, will become the square on the opposite plus the square on the adjacent. All right, so over here we are having 13 squared as 169, then plus 12 squared is 144. Then our arrow square will eventually become, if we add up this, 9 plus 4 is 13, carry 1, 6 plus 4 is 10 plus 1, 13, 1 plus 1 plus 1 will give us 3, so we are having 313 centimeter. Now, if we take the square root of both sides here, that is if we take the square root, in order for us to remove the square of both sides, we are going to have this, we cancel out this, we'll have the final answer for r to become, at this point we introduce our calculator. In introducing our calculator, we are going to press square root of what? 313. We press in our 313, and if you do so, you are going to have this, then you press equals to, you will have 17.69. so we are going to write that out, 17.69 centimeter, and that will give us the radius of this particular circle. I hope you are following me, and I believe you understand these steps. Now let's quickly go to example 2. In our example 2, we are told in the diagram chord PQ is 16 centimeter and radius OP is 12 centimeter. Now find the distance of the chord from the center of the circle. Give the answer to 1 dp, that is 1 decimal place. Okay, now this is the diagram. All right, we are given the radius of the circle, then we are given the chord, the chord length. Now you realize that the distance of the chord from the center, we need to represent it. And how do you represent it? By drawing a line from the center to touch the chord at that point, which is the chord midpoint. Okay, so immediately you do that, you write your mark, your 90 degree, and you divide your chord PQ into 2 equal halves. So 16 divided by 2 will give us 8. So we have 8 centimeter here, and we have 8 cm here. So now we are required to look for the chord distance from the center, which is what? D. So once again, we are going to apply our Pythagoras theorem. So we take the solution to this problem here very quickly. All right, so from what we have here, we are taking the square on the hypotenuse, which is your 12 square. Don't forget we are using Pythagoras theorem. Then d square plus 8 squared, 8 squared. Our 12 squared is 144, and then we have our d squared plus 8 squared is what? 64. Then finally we are going to collect like terms. D squared remains where it is. Then we are moving 64 to this side. We have 144 minus 64. I would like us to bring it here. So which means that our d squared will become, if we subtract this, we are going to have 80. So 144 minus 64 will give us 80. Now at this point, we are going to take the square root of both sides so that we can obtain the value for d to equals. Now we bring in our calculator once again. We put in our root sign, and then we press in our 80. This is our 80, and this will appear. Then we press our equals to. Then we have 8.94 centimeter. So we have 8.94 centimeter. But recall that from the question we are asked to give the answer to 1 dp. To 1 dp means this is the decimal point. 1 dp means this first digit. Consider the second digit, which is for rounded down as 0. So your answer will become 8.9. The 4 will be rounded down to 0 centimeter. Then you put your bracket and you write 1 dp. So this shows that you've approximated to 1 dp. So that is the answer to this second question. I believe it's quite interesting, and you are following the explanations. Okay. Now let us take a third example, which will be the final example for this lesson. And in this example, we are told here that in a circle of chord, a chord 8 centimeter long is at distance of 3 centimeter from its center. Now find the length of the chord, which is at a distance of 4 centimeter from the center of the circle, of the same circle. So which means, in taking the solution, you realize that from this question we are having 2 chords in a circle. So let's represent the circle. Let's draw the circle first of all. A wonderful circle that is. Okay. Then this is the center of the circle. We indicate that. Now let's take the first one. It says in a circle, a chord 8 centimeter long is at distance of 3 centimeter. Let's represent this. Okay. So let's assume that 3 centimeter is quite closer to the center. So the chord distance is 3 centimeter. And of course, you know that the length of the chord here is 8 centimeter based on the information given to us, which means that as long as you've drawn this line from the center to touch the chord at the midpoint, that means here will become 4 centimeter and here will become 4 centimeter. All right. Now we are also told that find the length of the chord. This is another chord which is at a distance of 4 centimeter from the center of the circle. We are looking for the length of another chord, and in this case the distance of that chord is 4 centimeter, which means the second chord will be quite shorter to the first chord. Okay, so here we have 4. Can put it here as 4 centimeter. Don't forget to put your 90 degree. Okay, so let's assume here to be M1 and also here to be what? M1. Don't forget that the line from the center will bisect the chord into 2 equal parts. So that's why we are having M1 and N1. Now what is missing in this diagram? You will realize that the radius is what we do not know, and we can calculate the radius from this first value that is given to us. Let's assume this is chord P and this is Q and this is A and here is chord B and this is the center of the circle 0. So now if I also draw this other line, don't forget that the radius is constant, so whatsoever I have here will also apply to this place here. So which means that if I know the radius and I put it here, I can use Pythagoras theorem to get this side and multiply the result by 2 to give us the length of the what? Of the chord. So let's start up by looking at triangle POM. So you will say in triangle POM, we are applying Pythagoras theorem. So arrow squared would become 3 squared plus 4 squared, and that will give us arrow squared to equal 3 squared is 9, which is 3 times 3, 4 squared is 4 times 4, which is 16, and if we add both together it gives us what? 25. That is, arrow squared equals to 25. Then we can take the square root of both sides in order for us to have the value for r. So this root sign will cancel this, therefore our arrow will become 5 centimeters. So which means the radius you are seeing here is 5 centimeters, and that's what we shall be applying here also, 5 centimeters. Okay, so let's call this BAOM. All right, so we come up here to solve this problem. So we say in triangle AOM, that is this triangle that is here, we are still going to apply Pythagoras theorem. We know this length, we know the hypotenuse, but we don't know this side. So we can come to say our hypotenuse squared, which is 5 squared, is equals to M1 squared plus 4 squared. 5 squared will give us 25, and m squared still remains m squared sub 1, then plus 4 squared is 16. Now if you collect like terms by setting 16 to the left side, our m squared sub 1 will become 25 minus 16, and 25 minus 16 will give us 9. That is, m squared 1 is 9. Then we can take the square root of m squared sub 1 and then square root of 9, and that will give us our m sub 1 to become 3 centimeters. Square root of 9 will give us 3 centimeters. So, but our aim is not to look for M1, but to look for the length of chord. So, you will say length, therefore, the length of chord what? AB, of chord AB will be equals to, don't forget that M1 plus M1 will give us 2M1. That is, we are going to multiply 2 to the result we got for M1, and that will give us 2 times 3, and 2 times 3 will give us 6 what? 6 centimeters, and that is the length of this particular chord. You can see that the length of this chord, 6 centimeters, is shorter than the length of the other chord, 8 centimeters. So the longer the distance, the shorter the length of chord. The shorter the distance, the longer the length of chord. That's the property we applied here. Now that brings us to the end of this lesson. Quite interesting, and I'm sure you actually enjoyed this lesson. We started out by looking at lots of examples. We gave the definition for what a chord is, and then we went on to look at the chord properties, which 6 properties we are given. Okay, 6 properties we are given, and from the properties that we are given, we went on to solve some examples, and you can see the first example we got the answer as 17.69 centimeter. The second example we got the answer as 8.90 centimeter to 1 dp. Then the final example here, which is something we just solved, we got the length of the chord as 6 centimeter. I would like to wrap up this lesson by giving you this assignment, although the answer to the assignment is already here. So just try your hands on this assignment. Don't be scared. Follow the video explanation that I've given in this video, and I'm sure you will arrive at this answer. Thank you for spending this time, and I would like to see you in my next lesson. In our next lesson, we are going to be talking about more questions on circle geometry, chord properties. We'll be looking at some advanced questions. You would not want to miss that lesson, so stay tuned. See you in my next class.